steady state optimization. The next point is PPT. So these we control. All things the container we are discussing these points. Already the automation process is there. Automation levels are there. Okay. So for that, of that, what are the things we need to consider? So from that, the automation with respect to continuous process as with respect to discrete industries can take a measurement. So in order to improve that automation levels. So in that we have gone through regulatory control and feed forward control. Next, steady state optimization. That. So now we have came across that what is feedback controls or feed forward control system. In feed forward control system, we are going to consider a primitive actions or primitive measurements will be taken in order to avoid the error. In order to avoid the error. So here in this steady state optimization, the open loop control systems uses the performance measures and also uses the optimization algorithms and also uses the mathematical method models. Okay, so in order to determine what are the parameters, input parameters, and also what are the process for driving the system. Okay, so here in this it will be considering all those things, mathematical model process, optimization algorithms, and also we are going to consider what are the two things to determine the input parameters as well as the things to required for the processing of the drive. So all those things it will be taken care of by this steady state optimization. Okay, so what are the input we are giving? So the same with respect to that, the external conditions like it will be there, so which will be having some variation with respect to the with respect to input variations. So all those things it should be taken into consideration. Then we are going to execute the, then we are going to prepare the thing for the driving process. Okay, so from this, there will be excellency of the performance will be taken place with respect to a suitable input which has been given to the system, then the suitable output will be coming out from that. So that we are going to call it as a steady state optimization. Optimization means we will be using a different techniques to in order to improve the quantity or the design or machine, whatever it may be. So next, adaptive controls. What is this adaptive controls? So in this adaptive controls, so to overcome the disturbances, to overcome the disturbances, okay, and also which capable of using an feedback control system, and also combining all those what are the things with respect to steady state, what are with respect to disturbances, and also an adaptive control over the feedback control system. So all those are things combined together, and it will be applied over the system. Then with respect to the system, what is the control system it is going on? With respect to that, what is the process it is going on? Then with respect to the thing, what will be the output we are going to get? Okay, from considering the previous step like steady state optimization, we need a control over all those things. We need a control over what are the input it is going. We need a control over what are the process it is going on. We need a control over what is the output or the feedback loop signal it is coming from the output. Okay, so all those things should be get combined in a practice. So the improvement should be made. There are three principles in this: identification function, decision function, okay, and modification function. So in the adaptive control system, we are going to consider three principles functions. One is identification function. Means the current index of the based upon the feedback it is coming out from the system. Then if you go for the decision function, here it will be determining what changes has to be made to improve the performances. What changes has to be made to the improve the performances, and also the what alterations should be made for the input parameters in order to get the a proper output. So that will be decision function will be carrying out the principle. Then modification function, which implements a decision function's output. Okay, so now, so during the process, I got some error. Then that error is identified. With respect to that error, I am going to take a decision. So and so decision it has to be get made. So in order to avoid that problem. So then the decision function has been made with respect to given input. Then modification function. So with respect to given input, okay, from the decision function, then the system will be taking or implementing or modifying the changes what it has been obtained from the decision function to carry out the or in order to get the required output. So that will be taken place in the adaptive control level. Then online search strategy. Okay, online search strategy. So it is to improve the objective adaptive control decision functions, and also some the decision functions are cannot be sufficiently defined. Then with respect to this, it gives the relationship between input parameters and also performance. Okay, to take the action. Okay, so online search strategies. So we have came across many strategies for the um, automation. So how many strategies we came across? We came across 10 strategies. Okay, we came across 10 strategies. So which we required for improvement of this process. For the improvement of the process, the same thing here we are going to take the online search strategies. So from that, if any requirement is there for the taking the improvement of the adaptive controls or improvement of the steady state things. So with respect to previous one, steady state optimizations, and also feed forward control fund control, and also regulatory control. So all these strategies, it will be if any some sort of things it can be developed with respect to this online strategies. We can make a one decision over that. We can avoid the errors. Okay, by considering the trial and error methods in order to obtain the a proper output by using the online search strategy. Then last one is others. So this others means which will be involving learning systems, export systems, networking, artificial intelligence. So I can say again it is on one more updated level. Artificial intelligence and also Internet of Thinking, IoT. So all these things are now combining. Okay, so with respect to the programs, what means I can say with respect to the word others. So it's a continuous process of learning. Okay, with respect to networks, with respect to artificial intelligence, and with respect to some neural networkings. So all those things, it will be having the continuous process has to be get worked or to improve or to implement on the automation system. So these are the different strategies, or these are the different objectives, control objectives for the continuous control system. The first one is regulatory control. Second one is a feed-forward control. Feed-forward control. And the third one is steady strategy control. Next, steady state optimization. Then adaptive control, online search strategy, and others. Then the next one is computer process control. Computer process control. So can you say this? What is this continuous? The definition is also there only. Just read me and explain what is the first step. Process initiated interrupts. Time initiated actions. Computer commands to process. System and program initiated events. Operator initiated events. What is that? Yes. Now the first one is process initiated interrupts. What is this process initiated interrupts? So that you can just I will read out the line. Okay. Uh, Controller must be able to respond the incoming signals from the process. So can you tell me different controllers? Control engineering, you studied different types of controllers. Anyone? ಸರ್ ಈ ಸೆಮಿಸ್ಟರ್ದೇ ನೆನಪಿರಲ್ಲ, ಇನ್ನು ಹಳೆ ಸೆಮಿಸ್ಟರ್ ಕೇಳಿದ್ರೆ ಎಲ್ಲಿ ನೆನಪಿರುತ್ತೆ ಸರ್? ರೈಟ್.
ಇಂಟಿಗ್ರೇಷನ್ ಕಂಟ್ರೋಲರ್.
ಎಸ್, ಇಂಟಿಗ್ರೇಷನ್ ಕಂಟ್ರೋಲರ್, ಗುಡ್.
PI, PD, proportional controller.
Yes, right. Proportional controller, integration controller, differential
Proportional
controller,
integrator.
PI controller, PD controller, PID controller. So these were the different controllers which we'll be using, and we were discussing these controllers are the art of the control system. Total the measurement and corrective actions, it will be taken with respect to this itself. Now we are saying process initiated interrupts. He is saying controller must be able to respond to incoming signals from the process. That is first point. So it should respond over what are the inputs it is coming to the process. And this may involve prioritization tasks to be performed by the computer as the emergence of the higher priority issues must be deal with the first. Means according to the requirement or according to the emergency, we need to set a program or anything or a signal or anything. So according to the higher priority, okay, then that task should be, this process initiated should be carrying out. The process should take the with respect to the emergency of the priority issues. Then example he has given here. Abnormal working condition required immediately corrective action taken place. Now the process is going on. Okay, now the process is going on. Some program I have given. According to that program, the work is carrying out. Suddenly, if there is an interruption in the work or disturbance in the work, what this controller has to be, it has to consider what are the signals it is coming from the feedback. Then with respect to that, on higher priority, you should take the actions for that in order to make a corrective action immediately. Okay, so that will be coming under the control requirements of computer process controller. That first one is process initiated interrupts. Then time initiated actions. What is this time initiated actions? Yes, again he is saying that controller must have ability to implement certain actions at a specific point in time if necessary. And also he has given examples for that. Sensors, switches, motors, and other binary devices in process are necessary. Okay, so here we should define, or we should have the controller must have ability to implement certain actions. Okay, ability to implement certain actions at specific point of time. Then with respect to that, he has given, okay, the range will be from milliseconds to certain minutes depending upon the type of the action to be performed. Okay, so he is saying that what all the things he has given with respect to sensors, switches, motors, on and off things, it will be there. It takes place from milliseconds to some, it will be taking several minutes. Okay, the time initiated, I can say suppose the just it's an outside example, like brake, if I consider a brake times and all, so the machines will be under working condition, then the normal general shifting times. Okay, shifting time also we can consider one operator will be getting it with respect to the next shift operator. So and then at that time we will be having these setups on of binary devices. Okay, other binary devices operations will be carried out based on the necessary requirements. Then next, computer commands to process. Computer commands to process. So the process, we have a input signal, we have a controller, we have a plant, we have a process. The plant also called as process. Okay, the plant also called as process. Okay, here the computer commands to the process or a plant. So the controller must be able to send. So here you need to notice one thing is, we're taking the control by the computer. What all the operation it is carrying out, what all the process it is carrying out in a plant array, in any machine. Okay, by giving the commands or by giving the control actions. Same way, the third point, computer commands to process. Here the computer is giving a command to the process. Okay, and that command should be obeyed by the process. According to that, it should have a proper action should be taken place by the process or a plans to carry out the work. That is also one of the requirement. Then system and program initiated events. System and program. So you can see system and program. What is that system and what is that program? So here he has given it relates to commands that has been passed between the program, computer system to itself or to other devices. Okay, the system and the pro. So we will be having like if I consider a normal system itself, if I consider a normal thing itself, like one system will base, it will be printer will be there, and also some monitor will be there. Everything it will be there. So there will be some. He has given an example. So control communication between the monitor and the printer. Now I will be giving the instructions or the commands to the monitor to take the printout of the sheet. So what are the thing we require? So here it will be instructing. So that is the communication initiated between the or the commanding or the instructions between the system and the program. So it is having a control. If I need a one sheet, it will give. So with respect to system, I need a one sheet, then two sheets, three sheets. So according to the given commands within the system itself or with respect to its devices, it will be performing the operation. Okay, so the control will be there itself. Next one is operator initiated events. So this is an instruction between the operator. Okay, controller must able to accept the inputs from the operating person. The operating person means the person who is giving a command like I need a one sheet, I need a two sheets of printout. Okay, or is the person who is having a giving the input to the system or giving the program to the system. Okay, so loading the program to the system and performance instructions, all those things it will be initiated between the operator and the system. So these are the connectivity between the person, system, machine, process, time. So it is a connection. So all these connections should be in a one required predefined program. Then only we are going to get the required output. Okay, these are the requirement of the controlled requirement of the computer process control. Okay, any doubt here? Any doubt?
Nothing, sir.
Okay, next one. The other forms of computer process control. Okay. Uh, the another one is and one more thing. Yeah, right. It's right. No problem. Okay, so you can take with respect to what we so those we will be considering as an important control things. So mandatory, I can say primary requirements of the computer process control. And with respect to that, type of the various types of control processing, monitoring, and processing control systems. In that, we are going to consider computer processing monitoring and digital direct digital control, numerical control, programmable logic control, and supervisory control, and distributed control, and PC program control, enterprise wise integration of factory data. So these things we have already studied. Okay, we have studied process control monitor. Okay, that we can take one more thing about. Then you people are direct digital control. Okay, we can. But you studied numerical control of robotics, programmable logic controller, supervisory control, distributed DNC, DC, DNCs, distributed numerical control systems, and pieces in process of controls. So you have some overview of that. That is now we can take one by one. So what it will be taking place. The computer process monitoring. Here, the computer, it will be observes, it collects, and it records the data of the process, but it cannot be used directly for the controlling the process. It will take all the data. It will take observation. It will carry out the observation. It will show where the error is there, what type of error it is there, and it saves the data. It collects the data, but it can give a warning message. But it cannot give a. It cannot go for now. If you are carrying out this one CATIA or a solid software itself, if there is no proper assembly is not there, it is not going to assemble. It will show some sort of warning messages. So and so it is not there. It is not linked. This point is not joined. Like that, some sort of things it will be giving a warning, but it is not going to take the primitive or directly control the process. So your control is human oriented, but that with respect to that human oriented, so that person will be changing, or that person will be seeing the data or collecting the data and making the decisions with respect to what all the error it has been occurred. So like that, here also we have three types of data are there. In computer processing monitoring, we have three types of data. One is process data, the another one is equipment data, and the third one is program data, product data. Okay, it will take what all the process data means. It will take all the input, output parameters and variables. It will be get and it will be get stored. And equipment data, it will be having a monitoring over what is the speed, what is the structure, the working of the total, the operations it can be carried out. So with respect to breakdown data, everything it will be there in the equipment data. Then product data, how many, what type of the product it is coming, that how many products are coming out, number of products, volume of product. So all these things it will be get stored in the computer processing monitor, which will be helpful for the control process. That is the thing related to computer processing monitoring. Just in the examination, with respect to words, if you keep remember the highlighted words, computer process monitoring. Monitoring ಅಂದ್ರೆ ಏನು? So you will be watching the, you will be observing, you will be checking something, and with respect to that, you will be taking the note of that. Okay, taking the note of that. So just with respect to that word itself, you can give the explanation to that thing. Next, direct digital control. So direct digital control. So this direct digital control means, so it is the computer which will be controlling the, or after taking all the data, after considering what are the different things, observations and all, the computer itself, it itself will be having a control over the what are the process or the what are the thing it is going over the automation. Okay, so here just nothing to say in this. So it will be directly having a control over the control system or over the machine. Now the technology has been improving, increasing more and more. So with respect to that, we got numerical controls. With respect to that, we got DNCs, direct numerical controls. With respect to that, we got distributed numerical controls and else we got. So as it is a direct digital controlling over the manufacturing process. Okay. So next one is numerical control, numerical control and robotics. So we already studied numerical control. We'll be giving a set of instructions to the program, set of instructions or programs to the system or to the machine, and it will be performing the operation according to the given set of that instructions. So then we are going to obtain the output. Okay, and also robotics. So the robotics also I can say it is related to numerical control. Robot arms, manipulators are controlled by the movement of the arms, jointed arms, with respect to the sequence of instructions which has been given or which has been defined in the memory. Then it will be performing the same cyclic work with respect to given instructions. Okay, so it itself it will be having a control. Okay, what according to the given instructions, the own controlling, and it will be now updated things are coming. Okay, next one is supervisory control. Sorry, not a programmable logic controllers. So in this programmable logic controllers, so microprocessor based controllers, it will be used for storing the instructions, the programmed instructions, and also the logics, and also sequencing, and also time, counting, and also other control functions for controlling the machine and the process. With respect to that, all the storage it will be taken place in the PLCs. Okay, programmable logic controller. Next, supervisory control. So in the supervisory control, supervisory. Okay, so what are the thing you have been given activities, a number of units like our production machineries, or number of units, okay, and the predefined parameters of the process. So what all it has been given with respect to that, the things are going on. So it will be also with respect to the automation control itself. So it itself can take a required measurement and it can deviate, or it will be giving a warning measure to the input, so such as to take over the what are the disturbances or what are the causes it has been caused to give the corrective action. So that will be taken out in the supervisory control. Then distributed control numericals. Distributed control system, we know already. Now CNCs means one system will be handling like 3 to 4 or 5 machines, but in the distributed numerical control system, one computer, supercomputer, it will be having a command over 3 to 4 computers. That 3 to 4 computers, it will be having a command over one computer with respect to 5, 6 machines. Then like it will be distributing the path in order to carry out multiple working and also huge production. Okay. Okay, so huge production. So then this we are going to call it as a numerical. So it is in now the process distribution and all the almost all the factories, industries. This type of the work is going on. Then pieces in process control. Okay, so we are going to include the pieces itself in the operator level. So in order to over a direct control over the automation process. Okay, so in order to get a direct control over the automation process, the pieces are involved, implemented, are designed in the process control itself. So there and there itself, we can avoid what are the disturbances. So in order to get a proper required output. So these are the different things which will be involved in the controlling of the process. The another one, enterprise level integration of the factory data. Okay, so here it will be users like PCs, flat out management structures, administrative tasks, and which will be done by the operator. So in order to have an extension over, networking technologies. In order to have extension over networking, so main thing in order to achieve the greater productivity. So in order to achieve the greater productivity at the factory level, okay, with respect to the data which has been collected, which has been observed from the previous things. So that we are going to call it as an enterprise wide integration of the factory data. So now these are the different forms of other forms of computer processing control. The computer process monitoring, the you can explain from the word, and direct digital marketing, digital controlling, numerical control, program logic control, supervised control, distribution. So all these things you will be able to explain and keep in a memory with respect to these words itself. Okay, that's why I'm saying instead of seeing all the it is a theory, it's a theory subject, but you people should do one thing is you should make it in a point wise, and you should write a figure, and the point wise explanation should be there. So ಆತರ ಇದ್ರೆ, so the evaluator will be feeling very much comfortable for doing the valuation, and they will be allotting maximum marks to the questions that which you attended through point wise. The questions which you attended through paragraph, you will be awarding less marks. Okay, that's why I'm saying you can write all the things in the point wise itself. Okay, 1 minute. Yeah, so this will be completing the module number 5. So we have gone through CNC technologies, part programming, and we have gone through what are the automations, what are the strategies, what are the basic elements, and also what are the levels of the automation. Then also we have went to what is the process and also discrete manufacturing industries, and we have given the differences. And the last topic was other control system components,